Mr. Arup Majumdar. He is the CEO of Trariti Consulting Group. He has been in leadership roles in consulting, industrial building, etc. industries, and for around 3 decades he worked abroad with top Fortune 500 companies. The exposure enabled him to appreciate cultural diversity, norms of doing business globally. Coming with an engineering background and MBA from IIM Ahmedabad, his skills on strategy development, innovation, multicultural leadership, business transformation, operational execution helped increase revenues. Mr. Arup is passionate to bring out the best in organizations, especially during the turbulent times. Mr. Arup will deliberate upon smart HVAC systems and innovations to drive business growth. So delegates, let's welcome Mr. Arup.
When this topic came to me about talking about smart HVAC systems, I was thinking that it's easy to talk about technology because you can all Google it. But what is important to understand that is how you use this technology in terms of developing the industry as a whole, and how do we make sure that we remove those bottlenecks which are impeding the rapid acceptance and introduction of certain technologies. I'll start off by talking about the technology shift that we're seeing in the HVAC space. We started off with mechanical improvements, trying to improve the efficiency of certain components. We then moved on to electronic performance, going from an AC inverter to a DC inverter. We did the refrigerant change, went from 22 R22 to 410A, now to R32 HFO blends. So we have moved in that direction on to areas of where we are using more of AI, cloud, and data. So now we are moving into a space which is moving fairly rapidly away from mechanical improvements to more of electronics and communication. And that is where the big picture is coming to us, that how we can integrate more of electronics, communication, and the power of computing and the cloud in order to enhance the services to the people who are going to use it. If you look at the typical air conditioning system, I'll talk about both air conditioning and refrigeration. We used to earlier think of a box. Everybody has a split AC at home and it's a discrete box. But now we are going to a fully integrated solution. We're moving rapidly towards it, different stages of adoption. So now we are moving to an area of a fully integrated home where not only the appliances, but many other aspects of the building is, or a residence is joined together. For example, the security system, the lighting system, the garage, and now with the advent of the electric mobility, the electric charging stations in the homes. So now we are talking about a fully integrated system where all the equipment which uses electricity in some form or the other gets connected into a centralized system. That is what we're moving towards. So when you talk about IoT, just to give you a brief on when you talk about IoT, there are three technologies we are talking about in IoT. The first is smart sensors, and sensors play a very important role in all this process because that is the place where information is picked up. The second one is internet connectivity. Connectivity to mobile devices as well as to remote storage places where you are storing data. And then you have cloud storage and computing, because now when we are taking information as we speak and in milliseconds, we're taking a large amount of data. So we have to process that data, and for that we need large computing power, which is easily available now to the cloud. All this is making comfort cooling easier. This is making machines more intelligent, and they're able to understand, they're able to do enterprise management. We can do fault detection, diagnostics, asset management, predictive maintenance, a whole host of value-added activities that you can do once you have real-time data available with you. We have the power of ML and AI, which is enabling us to make better decisions based on certain historical data, plus machine using their own AI algorithms are able to figure out what to do in certain exigencies. It also allows for customization. The customization according to different zones, according to different needs, customization can also be done. So IoT as an overall overarching technology offers you several benefits which can be leveraged. Now, when we talk about smart HVAC systems, they save energy, money, and lives. Simple. If you look at the equation, there's a demand side and there's a supply side, and there's a sensor in between, which is a very important connection to link the demand side to the supply side. Now we have sensors of different types. We have pressure sensors, temperature, thermal sensors, movement sensors, particulate matter sensors, gas sensors, fire sensors. There are a whole host of sensors. So the demand side is where you calculate what is required for the occupant inside the space in terms of temperature, humidity, cleanliness, safety, whatever is the parameter. And you can choose a whole host of features. For example, if you look at number 2, a door sensor, a ceiling camera, and an occupancy estimation algorithm can actually estimate the room occupancy. And based on that, it can adjust the supply side, and the supply side has to optimize the delivery of the right amount of cooling or heating in order to satisfy the room. So you can see from the demand side, there are several things that you can do, and all is moving, you see, from more of the mechanical side to more of the electric or the electronic side. And that is a skill set. Over a period of time, people who are involved in this industry have to take into account, because typically HVAC has been a mechanical industry. But now that paradigm shift is happening, that we have to look more at electronics in order to make the system more sophisticated and take advantage of all the technology which is being, or the technology advancements which is happening in this space. This is a fairly complex picture. You don't need to worry about looking at all this. But the idea which I want to give to all of you is that if you look at this commercial building, then a lot of the parameters in this building can be controlled. And if you look at the top right-hand side, it basically talks about what you can do. You can improve or manage air quality, manage the energy performance, provide real-time data input. You can provide healthy and safe environment, maintenance. You can provide a whole host of activities, and it all boils down to information, data. So data from the building in whatever shape and form is taken to a centralized place. It is monitored, it is analyzed, and then algorithms will tell the system or tell the operator, whoever that person is intervening in the process, to do certain checks and balances to make the system working properly. Picture may look complex, but it just gives you an idea of what is the power of having sensors, data, and algorithms, along with a backup of cloud computing and servers to be able to address the needs of the building. Cooling as a service. This is slowly and increasingly becoming more important. I've given here 2 examples. I'll not go through the small fine letters which is given over here, but this is just an example to show that cooling as a service can be used for air conditioning and refrigeration. What does it mean? A simple analogy is that you pay for what you use. For example, if you consume electricity, you pay by the electric meter, that whatever amount of electricity you have consumed according to the meter, you pay for that. So cooling as a service, they basically says that you pay for the amount of cooling that you consume. So there is a provider of cooling services. It's a centralized place which provides cooling to different buildings. So the onus is on you to make sure that you consume less, so you'll be more aware that I have to be careful about my consumption. The guy who is the technology provider who provides the cooling solution, he has to ensure that his machine is more efficient, is more reliable, so that his operating costs are coming down. So both from a point of view of the guy who is supplying the cooling, as well as from the person who is consuming the cooling, it's important that they try to optimize their needs so that it becomes financially more economical. So both in cooling and in refrigeration, we are seeing this model, especially in other developing countries, it's happening, that cooling as a service is emerging, and that is going to make a lot of business model changes in the HVAC sector. Now, what is the impact on the service sector? We talked about technology, but what does it mean to the technicians? In our country, there are over 2 lakh of HVAC technicians. Today, if you look at our service needs, then we do it based on a time. Like in a year, your AC will be serviced maybe once a year before the season starts. But instead, now that you have monitoring through sensors, you know whether your machine really needs the service or not. So the servicing contracts that you have, instead of having it based on time, you make it based on requirement. Imagine the life of a AC technician. His life is basically busy during the summer months. Rest of the time, he's probably not very loaded. But if you go to if you look at the possibility of horizontal integration, which means that data is coming from different parts, and a technician is able to handle not only one appliance of one brand, but he's able to look at the holistic picture of what is required from a house, then his skill set also improves because he's able to not only service brand A, he can service brand B, he can service appliance A, he can service appliance B, but that needs a business model change, that you have a service network which now becomes, instead of a single company, single product focus, becomes a full service provider for the entire home. That leads you to have two kinds of models. One is the aggregator model, where you combine all the appliances or electrical equipment which goes on into a home, or you have a performance guarantee model where you ensure that when you service, you say that your machine is working at a certain level. Take a simple example. You bought a 5-star machine and you knew that it would save you a certain amount of energy. But after 1 year, after 2 years, is that machine still 5-star? Probably it is not. But how do you know? You can only guess. But if you have real-time data on the performance of your machine, you know whether it is still a 5-star or has deteriorated to the level of a 3-star. And that brings to the last point, that the integration of mechanical engineering and electronic education will become more and more important, because service technicians are more and more adept at the mechanical side, a little bit on the electrical side, but not much on the electronic side. And that is a skill set which needs to be incorporated in these technicians to make them more capable and upskill them over a period of time. Now I come to the business side of it, that why don't firms innovate? This is a very interesting exercise, that if you look at the Global Innovation Index of 2021, it says that India is ranked 46th. And out of the 5, the first Asian to come into the picture is Korea. So why don't firms innovate? And if you talk to the company owners or MSME owners today, what we hear is that, oh, we know our customers well. We'll know when they want something new. The future is forever. What is present is this quarter, this half yearly that we have to deliver results. There's no sense of urgency. We are too process oriented. You know, ours is HVAC industry, we are conventional. It doesn't move that fast, especially in refrigeration. Our profit margins are pretty low. We don't have resources. And I'm not in the innovative group, I'm short of innovative reasons. People will give you all kinds of excuses why they cannot be innovative. But then times have changed. Especially COVID has created a rapid increase in the pace of adoption of technologies, and we see how new technologies are coming in. And so we have to have a mindset change to be able to not only introduce, but accept new technologies as they come into the market. If you look at a business, then the true value adders are innovation and marketing. The rest is all cost, as was said by Peter Drucker. Innovation, whether it is disruptive or it is sustaining, it creates long-term competitive advantage. Innovation can be in the form of material, process, supply chain, marketing, business model. We talked about the service, which is the business model. We talked about product, which is the technology, which we talked about using IoT. Leadership in this industry is very important. And sometimes we play laggard. Like Saki was saying, that we tend to kind of modify things and take it from outside our country. Instead of that, why don't we invest in R&D? Our R&D spend is less than 0.5%, is about 0.45% as compared to other developed countries which are using 3 to 4% of their spending on R&D. We don't do that amount of R&D, and that is where we should invest. Consumer awareness is increasing. People are becoming more conscious of the fact that you have to protect the environment by going into something which is green. So this is an opportunity for low environmental impact product, which means lower energy consumption. And companies of any size, whether you're a small company or you're a large company, it doesn't matter. At different levels of maturity, whether you are early in the game, you are having simple press shops and sheet metal or whatever that is, innovation in any form is a sustainable advantage. With that, I'll end my presentation. I hope I didn't run